Dear students, how are you? I have come back again with another video, how to balance chemical equations. Before starting the video, I request you to subscribe this channel. First of all, we discuss the super trick which is used for balance the chemical equation. The super trick consists of 6 points. Among 6 points, the first point is that in the chemical equation, we have to balance first the metal atoms like zinc, copper, sodium, aluminium. We must remember that metal atoms are those atoms which are present on the left side of periodic table. And on second number, we have to balance non-metal atoms. For example, carbon, sulfur, chlorine, nitrogen. And again we must remember that non-metal atoms are those atoms which are present on the right side of periodic table. And at the third number, we will have balance oxygen atoms. And after balancing the oxygen atom, then at the end we balance the hydrogen atoms. We must remember that during balancing the chemical equation, we have to only change the coefficients. We cannot change subscripts, right? Only we have to change coefficients. We cannot change subscripts. Before discussing the examples, we first see that why balancing of equation is carried out. Balancing of equation is carried out in order to fulfill the law of conservation of mass. According to law of conservation of mass, total mass of reactants is equal to the total mass of products. The total mass of reactants is become equal to the total mass of products at that time when number of atoms of reactants become equal to the total number of atoms of products. So in order to equalize the number of atoms of reactants and atoms of products, we have to balance the chemical equation. Now we discuss some examples in order to balance the chemical equations. The example 1 is the simplest example in which carbon reacts with oxygen and form carbon monoxide. In this example, carbon has one atom in the reactants and carbon has one atom in the products. And oxygen has two atoms in the reactants and oxygen has one atom in the products. In this equation, we are observing that there is no metal atom which is present. So, we first balance the non-metal atoms. The non-metal atom is carbon. In reactants, the number of carbon atoms are 1 and in products, the number of carbon atoms are also 1. So, the number of carbon atoms are already balanced. And we see that the number of oxygen atoms in reactants are 2 and the number of oxygen atoms in products are 1. So, we now balance the number of oxygen atoms. We balance the number of oxygen atoms by using the coefficient 2. Now, when we use this coefficient 2, then the number of oxygen atoms become equal. So, at the end, we again recheck the equation. And we see that the number of carbon atoms become unequal. The number of carbon atoms in reactants are 1 and the number of carbon atoms in products are 2. So we use the coefficient 2 at this position. Now, the carbon atoms have become equal. Hence, this equation is balanced. And at the end, we again recheck that the number of carbon atoms in the products are 2 and in the number of carbon atoms in the reactants are also 2. And the number of oxygen atoms in the reactants are 2 and the number of oxygen atoms in the products are also 2. Hence, this equation has balanced. Now we take second example. In this example, magnesium nitride reacts with water and form magnesium hydroxide and ammonia. In this equation, the number of magnesium atoms are 3 in reactants and the number of magnesium atoms are 1 in products. The number of nitrogen atoms in reactants are 2 and in products 1. The number of hydrogen atoms in reactants are 2 and the number of hydrogen atoms in products are 5. The number of oxygen atoms in reactants are 1 and the number of oxygen atoms in products are 2. In this example, we see that metal atoms are also present along with non-metal atoms and oxygen and hydrogen. So, in this example, we will first balance the metal atoms. Here the number of metal atoms are 3 and here the number of metal atoms are 1. So, we will use coefficient 3 here. So, the number of magnesium atoms becomes same. Now, after balancing the magnesium atom, we balance the non-metal atom. Towards reactant side, the number of non-metal atom are 2 and towards the product side, the number of non-metal atom are 1. So, we use coefficient 2 here so that the number of non-metal atom becomes same. After balancing the magnesium and nitrogen atom, we balance the oxygen atom. Towards product side, the number of oxygen atoms are 6. So we use coefficient 6 here so that the number of oxygen atom becomes same. And at the end, we balance the number of hydrogen atoms. Towards reactant side, the number of hydrogen atoms are 12. So we use the coefficient 2 here so that the number of hydrogen atoms become 12 towards the product side. Again, we recheck this equation. In this equation, the number of magnesium atoms was 3 in the reactants, the number of magnesium atoms are 3 in the products, the number of nitrogen atoms are 2 in the reactants, the number of nitrogen atoms are 2 in the products, the number of oxygen atoms are 6 in the reactants, the number of oxygen atoms are 6 in the reactants, the number of hydrogen atoms are 12 in the reactants, the number of hydrogen atoms are 12 in the products. Again, we must remember that we first balance metal atoms, then we will balance non-metal atom, then we balance oxygen atom, then we will balance hydrogen atoms. Now we take the third example. In this example, copper oxide reacts with ammonia and form copper, nitrogen and water. In this example, the number of copper atoms are 1 in reactants and the number of copper atoms in products are also 1. Here, towards reactant side, the number of oxygen atom also 1. Here, the number of oxygen atom also 1. Here, the number of nitrogen atoms are 1. Here, the number of nitrogen atoms are 2, and here the number of hydrogen atoms are 3, and here the number of hydrogen atoms are 2. Here we see that the metal, which is copper, is already balanced. Then we will balance the non-metal. Towards reactant side, the number of nitrogen atoms are 1, and towards product side, the number of nitrogen atoms are 2. So we first balance the nitrogen atoms by using the coefficient 2 here, so that the number of nitrogen atoms becomes 2 towards reactants as well as towards products. Now we balance oxygen atoms. And before balancing the oxygen atom, we first balance the hydrogen atoms. Here the hydrogen atom becomes 6, and here the hydrogen atoms are 3. So we use the coefficient 2 here, so that the number of hydrogen atoms becomes 6. Now we observe that towards product side, the number of oxygen atoms becomes greater. Towards product side, the number of oxygen atoms are 3, and towards reactant side, the number of oxygen atoms are 1. So we use the coefficient 3 here, so that the number of oxygen atoms becomes same. Again we see that towards reactant side, the number of copper atoms become 3, and towards products, the number of copper atoms are 1. So we use the coefficient 3 here. Now again we recheck that the number of copper atoms are 3 in the reactants, and the number of copper atoms are 3 in the products. The number of nitrogen atoms are 2 in the reactants. The number of nitrogen atoms are 2 in the products. The number of oxygen atoms are 3 in the reactants. The number of oxygen atoms are 3 in the products. The number of hydrogen atoms are 6 in the reactants, and the number of hydrogen atoms are 6 in the reactants, and the number of hydrogen atoms are 6 in the products. So this equation is completely balanced. Now we discuss fourth example. In this example, aluminium carbide reacts with water and form aluminium hydroxide and methane. In this equation, we see that metal is present, non-metal is present, oxygen is present, and hydrogen is present. We will first balance the aluminium, which is metal. Towards reactant side, the number of aluminium atoms are 4, and towards product side, the number of aluminium atoms are 1. So we use the coefficient 4 here, so that the number of aluminium atoms become same. In other words, the number of aluminium atoms become 4 towards reactants as well as towards products. Now we balance the carbon atoms. Towards reactant side, the number of carbon atoms are 3, and towards product side, the number of carbon atoms are 1. So we use the coefficient 3 here, so that the number of carbon atoms become equal. In other words, the number of carbon atoms become 3 on both sides. Now we balance the number of oxygen atoms. Towards reactants, the number of oxygen atoms are 1, and towards products, the number of oxygen atoms are 12. So we use the coefficient 12 here, so that the number of oxygen atoms becomes same. And at the end, we check the number of hydrogen atoms. The number of hydrogen atoms are 12 towards the reactants. The number of hydrogen atoms become 24 towards the reactants, and the number of hydrogen atoms also become 24 towards the products. So this equation is completely balanced. Again we recheck that the number of aluminium atoms are 4 towards the reactants, the number of aluminium atoms are 4 towards the products. The number of carbon atoms are 3 towards the reactants. The number of carbon atoms are 3 towards the products. The number of oxygen atoms are 12 towards the reactants. The number of oxygen atoms are 12 towards the products. The number of hydrogen atoms are 24 towards the reactants, and the number of hydrogen atoms are 24 towards the products. Hence, this equation is completely balanced. Now we take this example 5. In this example, manganese dioxide reacts with HCl and form manganese chloride, water and chlorine. In this example, the number of manganese atoms towards the reactants are 1, and the number of manganese atoms towards the products are also 1. The number of oxygen atoms towards the reactants are 2, and towards the products are 1. The number of hydrogen atoms towards the reactants are 1, and towards the products are 2. And the number of halogen atoms are 1 towards the reactants, and the number of halogen means chlorine atoms are 2 towards the products. Again, in this example, we see that metal is present, non-metal is present, oxygen is present, hydrogen is present. So first of all, we balance the manganese atoms. We see that the manganese atoms are 1 towards the reactants, and manganese atoms are 1 also in the products. So the number of manganese atoms are already balanced. So we first know we will balance the number of chlorine atoms. The number of chlorine atoms are 4 towards the products, and the number of chlorine atoms are 1 towards the reactants. So we will use the coefficient 4 here, so that the number of chlorine atoms become 4 towards the both sides, towards the reactants as well as towards the products. And then we check about the number of oxygen atoms. Towards the reactants, the number of oxygen atoms are 2, and towards the products, the number of oxygen atoms are also 1. So we use the coefficient 2 here, so that the number of oxygen atoms become same. And at the end, we check about the number of hydrogen atoms. The number of hydrogen atoms are 4 towards the reactants, and the number of hydrogen atoms are also 4 towards the products. So the number of hydrogen atoms have also balanced. Again, we recheck this equation. The number of manganese atoms are 1 on both sides. The number of oxygen atoms are 2 on both sides. The number of chlorine atoms are 4 towards reactants as well as towards products, and the number of hydrogen atoms are also 4 towards reactants as well as towards products. After balancing these 5 important chemical equations, we have given you a self-assessment activity. In this self-assessment activity, methane reacts with oxygen and form carbon dioxide and water. So you have to balance this chemical equation, and you have to reply the answer in the comment section. Thank you very much for watching this video. And if you do not have subscribed this channel, then please subscribe this channel, so that every new video reach up to you soon. Again, thank you very much.